Hello and welcome to my YouTube channel. Today we are going to dive into the concept of support vector machine, or commonly known as SVM. This powerful algorithm is widely used in classification tasks within machine learning. Let's take a closer look at this image to understand how SVM works. Let's now understand a few basic concepts and answer the questions. What is support vector machine? A support vector machine is a supervised learning algorithm used for classification and regression tasks. However, it is most commonly used for classification. The main idea behind SVM is to find a hyperplane that best separates the classes in the feature space. So let's now understand the image. In the image, we can see two distinct sets of data points represented by blue and red circles. Each set belongs to a different class that we want to separate using a hyperplane. So what is a hyperplane? The green line in the middle is called the hyperplane. In the two-dimensional space, it is a line, but in the higher dimension, it becomes a plane or a hyperplane. This hyperplane is the decision boundary that separates the different classes. SVM aims to find the hyperplane that maximizes the margin between the two classes. The margin is the distance between the hyperplane and the nearest data points from each class. The nearest data points are called support vectors. The black line on either side of the hyperplane represent the margins. The goal of SVM is to maximize this margin to ensure that the classes are well separated. So what is support vectors? The support vectors are the data points that are closest to the hyperplane and are critical in defining the position and orientation of the hyperplane. In the image, the support vectors are highlighted with the arrows pointing to them. These points lie on the margin boundaries. So let's now understand how the SVM works. Training the SVM is the first step. During the training phase, SVM tries to find the optimal hyperplane that best separates the classes by maximizing the margin. This involves solving an optimization problem to ensure that the hyperplane is positioned in such a way that the margin is wide as possible. The next is classifying new data points. So after training, once the SVM model is trained, we can classify new data points by determining which side of the hyperplane the points fall on. If a new point falls on one side of the hyperplane, it is classified as belonging to the blue class, and if it falls on the other side, it is classified on belonging to the red class. So, what are the advantages of SVM and using it after using it? Effective in high dimensional spaces. SVM are particularly effective in high dimensional spaces and can handle cases where the number of dimensions exceeds the number of samples. Robust to overfitting is the second advantage. In SVM, SVMs are robust to overfitting, especially in higher dimensional space, as they focus on the points that are most difficult to classify. So, after listening to all these concepts of the SVM, the conclusion is that the support vector machines is a powerful tool for classification tasks, offering robust performance even in the high dimensional space for finding the optimal hyperplane and maximizing the margin. SVM ensures that the classes are well separated, leading to accurate and reliable predictions. Thank you for watching the video. If you found this video helpful, please give it a thumbs up and subscribe to my YouTube channel for more data science and machine learning content. Feel free to leave any questions or comments below.